Resid Hydrocracking, like conventional hydrocracking, is oriented toward making high-quality distillate fuels. It is considered to be a popular alternative towards thermal residue conversion technologies such as coking, visbreaking, etc. This is partly due to significant yields of distillate obtained from the process, as residue hydrocracking processes convert a significant portion of the bottom's range streams to lighter products. In fact, when processing atmospheric and vacuum residues, there is a significant yield of distillate fuels and vacuum gas oil obtained. Yields for resid hydrocracking can range from 60 to 95%, depending on the process. Selectivity to diesel can be as high as 40 to 55% with a number of commercial resid hydrocracking processes. Vacuum gas oil produced from resid hydrocracking can be processed in downstream conversion units such as conventional hydrocracking, FCC, or RFCC to yield additional quantities of high-quality gasoline, diesel, and propylene. The presence of hydrogen in resid hydrocracking often causes the unconverted residue fractions to be hydrogenated and low in sulfur when passed through a resid hydrocracking reactor, which can be used for production of low-sulfur fuel oil. Furthermore, the use of hydroprocessing will result in lower levels of sulfur, nitrogen, and other contaminants in the liquid products compared to thermal conversion techniques. Process schemes for resid upgrading or hydrocracking are based on one of three types of reactor design: moving bed, or fixed bed for short, ebullited, or expanded bed, and slurry phase. Fixed bed units for hydrocracking resid provide the least conversion of the three types of reactors, and operate with higher quality feeds. Fixed bed units may be operated in two modes. In the first mode, about 35% of the 550 degrees Celsius or 1022 degrees Fahrenheit plus fraction is converted to desulfurized vacuum gas oil and fuel oil. The second mode conversion is up to 60% and products include vacuum gas oil along with some gas oil and naphtha. The unconverted resid is low in sulfur and is suitable as RFCC feedstock. The feed tolerable to fixed bed units can have at most 700 parts per million of nickel and vanadium, Conradson carbon residue in the range of 10 to 15 weight%, and asphaltene content from 3 to 8 weight%. Typical catalysts used for fixed bed reactors are made from cobalt molybdenum or nickel molybdenum on alumina silica, or zeolite supports. Compared to ebullited bed and slurry phase reactors, the catalyst loadings for fixed bed reactors are the most complex, comprising of multiple beds or layers of catalysts with different pore structures and activities. The different activities of catalysts include hydrometallization, asphaltene conversion, hydrodesulfurization, hydrodenitrogenation, and Conradson carbon conversion. Ebullited bed reactors use mixture of liquids and gases to expand the catalyst bed. This scheme allows for continuous addition of fresh catalyst and removal of spent catalyst, which helps deal with the concern of catalyst poisoning. Ebullited bed hydrocracking processes are appropriate for treating heavy feeds such as atmospheric resid and vacuum resid using catalysts with activities for hydrotreating, cracking, and removing metal contaminants. Previously, maximum resid conversion was reported to be 65%, but recent innovations have been applied to push this number up to 85% in some cases. Ebullited bed reactors are more capable of processing low-value feed compared to fixed bed units, as it can process feeds with more than 700 parts per million of nickel and vanadium, Conradson carbon residue in the range of 18 to 22 weight%, and asphaltene content from 10 to 18 weight%. Catalysts for ebullited bed reactors are generally the same as those for fixed bed reactors, which include those made from cobalt molybdenum or nickel molybdenum on alumina silica, or zeolite supports. The molybdenum in these catalysts is sometimes replaced with tungsten. These catalysts, however, have been shown to have limited conversion and may be subject to fouling. Catalysts in ebullited bed reactors usually have a smaller particle size than those of fixed bed reactors to help facilitate suspension and higher mechanical strength to resist abrasion. In slurry phase reactors, Finely divided solids or soluble compounds are dispersed in the feed and then carried upward with hydrogen gas through a tubular reactor. The slurry phase configuration addresses the problem of asphaltene access to catalytic sites. The reactive phase is a slurry or suspension, and high turbulence is not required to suspend the particles. Resid conversion can be as high as 95 weight%, with asphaltene conversion being more than 90 weight%. Slurry phase reactors can handle feeds with high nickel, vanadium, Conradson carbon residue, and asphaltene content, similar to the properties of those used in ebulated bed reactors. This diagram depicts a slurry phase resid hydrocracking process. Slurry phase reactor catalysts are typically either carbon, such as coal or petroleum coke, that have been impregnated with metal salts or dispersed organometallic compounds, such as metal naphthanates. Without the impregnating metals, conversion with solid catalyst would be primarily a thermal process, resulting in high yields of cracked gases and coke. The solid catalysts usually exit the process with unconverted resid. Recovery of spent catalysts is impractical, so they are instead discarded, burned, or gasified with the pitch after use. Dispersed nanoscale molybdenum disulfide catalysts, on the other hand, are capable of being recovered or recycled. Here is a non-inclusive list of companies that license fixed bed reactors, ebulated bed technology, and slurry bed reactors. Generally speaking, the major criterion for the type and amount of catalyst used in resid hydrocracking reactors is the control of coke formation in the reactor. While many companies design catalysts specifically for the company's licensed process technology, other companies offer catalyst technologies that can be applied in various fixed bed or ebulated bed units to improve conversion and activity. Here is a non-inclusive list of such companies.